All right, well, let's get started. So I'm really excited to be here today and get to talk to you guys about Angular 2. I've got a lot of links to resources and blogs in my slides, so if you want to grab the slides, you can at tinyurl.com/ng2slides. They'll also be up on the FITC site after the conference. So I wanted to do kind of an agile approach to this talk. So instead of building to a big conclusion at the end, I want to jump right in with something you can actually use. So let's start with the takeaways, or at least what I hope the takeaways will be from this talk. So first of all, I think Angular 2 is awesome. I'm going to be showing a lot of examples with Angular 2, and hopefully you'll get a bit of a feel for it. I promise it is much better than my slide-making abilities. There are a lot of barriers to entry with Angular 2, and the goal of this conversation or this talk is not to convince you that Angular 2 is good or bad, but it's really to lower the barrier of entry and to give you the tools you need to start learning Angular 2. So first of all, Angular 2 is still in alpha. It's changing pretty rapidly. There was an announcement just earlier this week saying they wanted to stop having breaking changes in the core of Angular 2, so the pace is going to start to slow down. But right now, it's pretty hard to find up-to-date resources and blog posts and sample applications to get started with Angular. Even on the Angular website, their getting started is like 10 versions behind on where they're actually at, and they introduce some pretty big changes in each version. So yeah, the goal of this talk is really to make it easier to start working with Angular. At first, it might seem like there's way too much to learn in Angular. It's a really big application, and it's also based on a lot of third-party technologies or standards. For example, it really takes advantage of things like ES6 and TypeScript, module loaders, the DOM. The DOM might sound kind of trivial, like of course a web application is going to use the DOM, but it actually lets you interact directly with the DOM instead of abstracting it away like a lot of other frameworks do. It also is heavily inspired by web components, uses observables, uses a library called Zone.js, which lets you sort of bring in any third-party library and it'll integrate nicely with it. And it also is heavily inspired and takes a lot of concepts from Angular 1.x. So this might seem kind of overwhelming that in addition to all the new Angular 2 features, you also need to sort of understand all these technologies it's built on. But it's actually a really good thing because it means that even if you aren't working on an Angular 2 project, you can start learning most of what Angular 2 is built on. And if you go into Angular 2 with a good understanding of some of these technologies, you're going to have a pretty easy time learning it. So it's up to you when you want to start learning Angular 2. It is pretty early in alpha right now. It's not really ready for production. But at the very least, you can certainly start learning everything it's based on, which will really help you once you actually get into Angular 2. So I'm going to be demoing a bunch of the features of Angular 2 and really only focusing on the ones that are based on technologies you can use in pretty much any project outside of Angular 2. So to get started, let's just build a Hello World app in Plunker, and we can go over kind of in detail a high-level overview of what each of these features is doing in a simple application. Okay, so I have some starter code here. It's not doing anything yet, but the first thing we're doing is including tracer runtime. So tracer runtime is a library that Angular depends on right now, so you just have to include it. It's something that Angular is not going to depend on in the future, so don't worry about it too much. They're working on removing their dependency on this. The next thing we're including is System.js. So this is a module loader. If you've used Browserify or even worked with modules in Node, this is kind of the same idea, but on the client. And System.js is a really robust and versatile system loader, or module loader. It can load just about any kind of module. So you can give it common JS modules, AMD. It has its own format of modules. There's also this new, I think, UMD modules that it can load. So it's a really useful module loader for a wide range of scenarios. And I'm going to be using it in all of the Angular samples. Now, the source code for Angular is written in TypeScript. And it's kind of their preferred language for writing apps with Angular 2. You don't have to use it. TypeScript, at the end of the day, just compiles down into JavaScript, or ES5. So you can use whatever you want. But in these examples, I'm going to be using TypeScript because there are some features that make it really nice to work with Angular 2 and TypeScript. But getting TypeScript working with ES6 modules in the browser, in a Plunker, is actually kind of tricky. Normally, with TypeScript, you would compile that all offline, get your ES5, and then you could load that into the browser. But in a plunker, we're going to need to do this all in the browser. So the next file I'm including is this config.js. And this is what is going to tell System.js how to load TypeScript. So this tells System.js how to actually transpile that TypeScript on the fly as it's trying to load in new modules. So basically, I'm just telling it, use TypeScript as a transpiler, and I'm pointing it at a plugin that tells it how to actually transpile that TypeScript. This other option I'm specifying, emit decorator metadata. This is a way to tell TypeScript to output the types you specify on it so that Angular can use them for DI, or dependency injection. I'm going to go into a lot more detail on that later, and we don't really need it at all for the Hello World example, so don't worry about it too much yet. OK, so next up, we are including the angular.js file. So this is the angular2.js file. So let's take a look at the source code for this. I have it open here. In the source code for it, you'll see a lot of calls to system.register, and then something like angular2/angular2. So basically what they've done is they've bundled up all of their modules and put it into this, this file here that knows how to register them all as System.js modules. So instead of me importing a module and System.js having to go make a network request for it or something, these are all bundled up in one file ahead of time. And when I include this script tag, System.js will go and add all these modules to its cache. So when I say I want to import Angular2/Angular2, System.js will know exactly what that module is actually exporting. The TypeScript, that comes later. The TypeScript modules are going to work kind of different. I'm not going to be bundling anything up ahead of time because I want to be able to write this all in the browser. And I'm not going to be adding any script tags for my TypeScript files. I'm going to just tell System.js to import a module called, for example, bootstrap.ts, and it will go and make a network request for that file and load it kind of lazily as needed. And this may or may not be a great workflow for production, just because you don't want to be making too many network requests, but it's pretty handy when we just want to play around with this in the browser or for development. All right, so to get started with an Angular 2 app, the first thing you need to do is bootstrap it. If you're familiar with Angular 1, it kind of had this ng app, which you could put somewhere in your code, in your HTML, and that's how the app started. In Angular 2, you need to import this bootstrap function from the Angular 2 module and call it to start the app. But this bootstrap function is expecting a component, kind of a root component for your app to start everything off from. So in order to start this, we need to actually create a component. So I have this app.ts file, not much in it yet. It's just importing these two things from the Angular 2 module. So all a component really is it's a collection of layout and logic, so like some HTML and JavaScript that you can plunk into your app anywhere. If you're familiar with Angular 1, it's like a directive with a template and an isolated scope and a controller or something. So to get started with it, I need to create an ES6 class. So I can say class, we'll call it app, and I need to tell Angular some information about this class, like how it's going to actually be treated as a component. To do that, I'm going to use this component and view. So these are actually decorators, which is a feature in TypeScript. It's also proposed in ES7, and Babel already supports it, so you can enable these decorators in Babel as well. So here's how you would go about using them. So you kind of annotate your class with these decorators, and we can give Angular some information about how this component's going to work. So for example, I can tell it what the selector is going to be. So if I say app, then it's going to look for a tag that's the word app. If I put it in square brackets, this is just a CSS selector. So now it would instantiate my component anywhere where there's an attribute where the word app is. And you can even do classes or whatever you want. But I'm just going to leave it as a tag that's the word app. And then we're also going to tell it some stuff about the view for this component. So in the view, I can specify a template. So let's just give it an H1, Angular 2. OK, so this is pretty much all we need to create a basic component in Angular 2. But now we need to actually load this component up. So in our Bootstrap, we need to pass this app into this Bootstrap function. But since we're using modules, none of this class or anything in this file is being globally exported or is on the global scope. So I need to import this as a module. And in ES6, if you want to export something from a module, you need to say export. So I'm going to export this app class from app.ts, and then I'll be able to import that in my bootstrap.ts. So in Bootstrap, I can say import app from app.ts, and then I can pass that into Bootstrap. And this will start my application. And the first thing Angular would do is look for that selector I told it about. So it'll look for a tag called app, which I don't currently have anywhere. So let's add that into index.html. All right. Add in our app tag. And again, I said I don't have any script tags for any of my TypeScript code. So in order to kick off this whole Bootstrap process, I need to import that Bootstrap module. So I can do that with a script and call system.import. And then we'll just import that bootstrap.ts. And moment of truth. There we go. We have our Angular component being bootstrapped, and it's loading in and getting that metadata that is specified in the decorators for our custom component. We can take this one step further. So in our app, we could create some variables and create bindings to those, or in this component. So if I say constructor, again, this is just an ES6 class. I can start, registering some variables here. So we can say this.test equals world, and then we could create a binding to that. So say div. Create a binding just the same way you would in like Angular 1. So if I create a binding to test and say hello, then we should get hello world. So now it's actually binding to basically any variable in our class. And TypeScript kind of has a shorthand way of doing this. We can just say test equals world, and then we don't really need the whole constructor. TypeScript likes you to kind of define all of your member variables ahead of time, so it can tell if you're misusing a member variable or something like that. But it's basically the same idea. So this is how you build a simple app in Angular 2. This took me an embarrassing amount of time to write the first time through, so it really helps to have kind of a jumping off point if you want to get into Angular 2. So it really helps to have an example, something like this, where you can actually start hacking with the Angular 2 features, not have to worry about how to configure System.js or something like that. OK, so next. As I was saying, I'm going to link to a bunch of resources. So if you want to start learning Angular 2 and keeping up with it, there's some good blogs and documentation and sample apps you can check out here. For most of this talk, I'm going to be demoing this app, NG2 Movies. It's just a simple little sort of IMDb app. So if you want to grab the code for that afterwards, you can get it here. But let's dive into the specific features of Angular and how they relate to technologies that are outside of Angular that you can start using in any app. So browsers have grown up a lot since the days when Angular 2 was first conceived, or Backbone, or Ember. And the DOM, in particular, has gotten a lot better. I know Douglas Crockford just got finished telling us it's the worst API ever designed, but it is getting a lot better. It's a lot more standardized, and there are some good parts to it. So in Angular 2, instead of abstracting away the whole DOM from you, it really lets you interact with it directly. In Angular 1, it had things like JQLite for selecting elements, which is gone in Angular 2. It had a bunch of custom directives for doing things like binding to DOM events or binding to DOM properties, and these are all gone in Angular 2. So instead, you just have a more powerful template syntax that lets you interact directly with the DOM. So let's take a look at how that actually works. As I said, I'm going to be demoing this little movie app. So here's basically all it does. So it's just a list of movies. You can click one. It'll take you to the details. You can go back. You can search them. Pretty basic, but it gives us enough to play around with some of the Angular 2 features. We've got multiple pages in here. We're loading all this movie data from a server. We're doing some two-way binding, which, yes, is still in Angular 2, sort of. So let's see how we can start playing around with the template syntax and accessing the DOM. OK, so the way this app is laid out, I have a source folder with basically all my code in it. It's pretty similar to the hello world. My index.html, again, is including tracer runtime, system.js, setting up system.js and whatnot. I have 3 components. So there's a root component, which is this app component. And then there's a component for each page. So there's a home component and a movie details page component. If we take a look at the home component, so this is the page with a list of all the movies. I've got all of my templates inlined and also all of my styles. Let's make those look like CSS. All of the styles inlined. If you're coming from an Angular 1 background, this probably looks pretty ugly to you. But if you're coming from a React background, you may be kind of used to starting to inline a lot of your layouts alongside your JavaScript. So Angular 2, the core team is actually sort of in favor of inlining your templates, and as long as you can keep them really small and having basically the entire component encapsulated in one file. So right now I have all of my logic for this component, all of my styles for this component, and all the layouts all defined in this one single file. But there are certainly some downsides to doing it this way. So the details component I've done the other way, where you kind of branch out to everything. So you just specify. You can also specify a template URL and style URLs to load in your styles, and do it kind of the more traditional way if you want. But let's take a look at how this template syntax is working. So first of all, let's look at this image tag. This is where we're loading up the poster for that movie. And we can see this new syntax where we have src surrounded in square brackets. So all this is doing is when you put square brackets around something, it's taking that DOM property and it's going to create a binding to it. So it will evaluate this expression and assign that to the source property. If without the square brackets, it'll just interpret this as a literal string, just as it would in any HTML file. You might think that you might be able to just create a binding and use just the direct source tag like that. But you can actually run into a lot of problems with this because the browser will try and load the image before Angular actually starts sometimes, and then it'll try and load this literally as the URL, which doesn't work. So in Angular 1, they solved this by introducing custom directives like ng-source, whereas in Angular 2, we can handle this just through our the new template syntax. Just by putting some square brackets around source, we can bind to that DOM property. And you can do this with any DOM property. There's also an alternate syntax for this. So instead of the square brackets, you can just say bind dash source, and this should still work. It should be doing the same thing as before. There we go. So yeah, it's still basically doing the exact same thing. It's just, if you don't like the square brackets, you can do it with bind dash. Let's go back to that. Okay, and you can do the exact same thing with events. So let's say we wanted to bind to an event. So I can create a button here, and we'll bind to a click event on it. So if I say button, toggle, to bind to event, instead of using square brackets, we're going to use round brackets. So this tells Angular, I want to bind to this DOM event called click, and it'll evaluate your expression whenever the click event happens. So we could do something like toggle a hide variable, say hide is equal to not hide, and then we could use that hide variable to show and hide the whole list of movies. And instead of using something like in Angular 1, a custom directive like ng-source, we could just bind to the DOM property hidden. So if I say hidden equals hide, it'll bind this variable directly to that DOM property of hidden. So if I try this again, now our toggle button will toggle showing and hiding that whole list of movies. You can also get direct access to just like a raw DOM element by creating a local variable. So if I do something like hash and then any word, it'll create a local variable that's equal to this element. So if I say hash container, I now have this variable called container that I can start using anywhere in my template. So if I wanted to do something like whenever there's a mouse over on the title, change the color of the font for the whole app, I could say mouse over, and then we're going to use this container variable we created to get the DOM element of this div tag. And we can say container.style.color equals red. And with that, whenever I mouse over this component, it's going to grab that DOM element, and it can then do whatever it wants with that DOM element.
Is there a bind dash syntax for the events as well?
Yeah, I think it's on dash. Let me just try that. Good point. Let's try on. So yeah, you can just say on dash instead of the round brackets. And just for completeness, we could do the same for mouse leave, except change it to black. So we say on mouse leave. Now, whenever I mouse off of it, it should go back to black. So you definitely want to use this pretty sparingly. You don't want to have a whole lot of just like imperative DOM manipulation directly in your templates. But it's a really powerful tool that allows you to, not need to learn a bunch of new custom directives or anything like that, and just work directly with the DOM. So I mean, a better way to do this might be to create a function in your actual class, like make red, and pass in that container or something like that. But this is basically how you work with directly with the DOM through the new template syntax. All right. So I've been talking a bit about ES6 and TypeScript, but haven't really described what those are. So if you're not familiar with them, ES6 is just the next version of JavaScript. It's got a bunch of cool new features. Not totally supported by browsers yet, so in order to use it, you need to transpile your code. And TypeScript is just a superset of ES6, and it adds in some things like those decorators we saw, and this optional typing system, which I'm going to demo in just a minute. So let me just get rid of all those changes I made to this home file. Okay, so first of all, we've already seen how these decorators work. This is a TypeScript feature. It lets us add all this metadata to our components. We've seen how these classes can kind of work. This is an ES6 feature. And as I was saying, TypeScript is a superset of ES6, so you can just use this TypeScript compiler to transpile all of this code into ES5. So if we take a look at, I have a gulp file running, and this is what's taking care of transpiling all my code. So I have a TS task that's going to take all of my TypeScript files and run them through this gulp TypeScript plugin, which will just transpile it down to whatever I tell it to. So I'm telling it to transpile down to ES5. I'm converting all these ES6 modules into common.js modules. I'm loading them with system.js, but as I was saying, system.js can load just about any kind of module, so it doesn't really matter what kind of modules you output. System.js should be able to handle them. And I'm saying emit decorator metadata. So what this means is basically anywhere you have a decorator, like that at component or at view, TypeScript will output the type information about all your constructor parameters of that class. And Angular can then use those to do dependency injection. So for example, if we look at that home component again, we can see this is how you kind of specify a type with Angular or with TypeScript. I say the parameter name, colon, and then the name of the type. And then because I'm using this output or emit decorator metadata, Angular can actually use that type at runtime to dependency inject this movie API. And the types in TypeScript are usually just a compile time thing. So that's why you have to specify this custom flag. They're usually just something you use to do some static analysis of your code and figure out what's working and what's not. But let's take a look at what TypeScript is actually outputting. So you can see I'm running it through this step, and then I'm outputting everything to a build folder. So if we look at the source for something, like let's take something really simple. We have this movie class here, which is just a pure data model. Here's all the fields it's going to have. We're getting them from the server and assigning them to these fields, and then it's got a function on it. So TypeScript is going to take this and compile it down to this, which is actually really readable. It's many times they write better JavaScript than I would. It's basically doing the exact same thing, except instead of using ES6 classes, it's just using a constructor function and prototypes. And instead of using ES6 modules, since I specified common.js, it's now doing it the common.js way, where you say exports.something equals something. So debugging the output of TypeScript is actually not that bad, because they do a pretty good job of outputting stuff that's pretty readable. We can take a look at a bit more of an advanced scenario where, for example, I have a movie API service. And this is injecting Angular's HTTP service. So that means that we're going to actually need to output this type information so that Angular can figure it out at runtime. So when this gets compiled down to JavaScript, there's some extra stuff in there. So we take a look at the movie API service. Here's basically, sorry, I went to the wrong file. Did I minimize something? Let me get out of here. I think I collapsed down the whole thing. All right, we can look at a different file. So my app file is going to inject that HTTP, or it's going to inject the movie API service. So it's going to need to output some information about what those parameters are. So you can see we're creating the component decorator and the view decorator. This is kind of how they get compiled down. And then we're also setting up some parameters here. So yeah, it should be telling it the parameter types, but maybe I'm not running the gulp file. Try to rerun that. Anyway, that's basically how TypeScript is working. Let's play around with some actual types and see what they can do for us. So I'm going to open up our home component and check out a branch that has some bugs on it. So if we run this now, it should have broken the whole app. It reloads. Maybe my node server went down. Okay, no, it broke the whole app. So that's what we were expecting. And we're getting this output, cannot resolve all parameters of home, make sure they all have valid type or annotations. So let's try adding some TypeScript types to this home component and see if it can help us track down the bugs here that are causing some issues. So we can take a look at our TypeScript output down here. I'm going to start by just assigning this search to an empty string, just initializing this variable. And with that, TypeScript can actually infer the type that the search variable is going to be a string. And it can start finding bugs for us already, even though I haven't actually told it explicitly what any types are. So you see it found this issue. Let's see, we can show the line numbers. So I found this issue on line 81 where 2 lowercase is spelt wrong. And it can catch that because it now knows this is a string, and it knows all the functions that are on a string. So let's try adding some more types. And I'm just going to minimize this view annotation so we can see a bit better. So I'm going to add the movie type, which was just that raw class I showed you, because this variable here is going to be an array of movies. Now, in order to get this movie type, I need to import that ES6 class. Basically, what I'm specifying for the type is just the class itself. Thankfully, WebStorm has some handy features where it can add those imports for me automatically. So you can see it just added this movie class for me automatically as an import. And I can do the same thing for movie API. So type of this is going to be movie API. And if I hit Alt-Enter, it should automatically add that import for me. And now we can see a bunch of things being highlighted in red. And also, now that we're actually telling TypeScript about these types, it's starting to find a whole bunch of bugs in our code. Also, we've actually already fixed one of the bugs. So we're getting a little bit further. We're loading the header. And the bug we fixed was that Angular was trying to use this type in order to inject the movie API, but it couldn't find any type because we didn't specify it. If you're not using TypeScript, you can specify the types with an inject decorator. So you can say something like inject and pass in the type like that. But if you're using TypeScript, you kind of just get DI for free if you're already specifying the types of your constructor parameters. So let's take a look at the sorts of bugs that TypeScript found in our code. So first of all, it's saying property success does not exist on type promise of movie array. So that's happening on this line here. And it basically knows that get movies is going to return a promise because in my definition of get movies, I told it what the return value was going to be. I told it it was going to be a promise that resolves with an array of movies. So it knows that there is no success function on promise. I can get autocomplete for all the functions that actually are on promise, and I actually want to be using then and not .success. So if we let TypeScript run again, we should see it's now finding this error, argument of type, and this is basically just a function that returns nothing, is not assignable to the parameter of type, a function that returns a Boolean. So this is happening on line 81. So here, now that it knows what movies is, it knows that's an array, so it knows what filter is. And it knows that filter takes a function that returns a Boolean, but it's saying you're giving me a function that returns nothing. And that's because I forgot to actually return the value from this filter. I'm just assigning it to this isMatch variable. So instead of this, I should be returning this, and that should fix that issue. So let's see what it comes back with now. It's saying property name does not exist on type movie. So right here, it's saying your movie class doesn't have a field called name. Now, no amount of staring at this code or even unit testing it is really going to find this bug. If you wrote this code and you think that movie has a name field, well, then you're going to mock out movie with a name field in your unit test as well. So it's really useful. TypeScript can actually sort of do simple integration tests of making sure that you're using all your types correctly. And if we take a look at movie, we see it has all these fields, and title is probably the one we meant to access. So let's use title instead of name there. We've spelt lowercase wrong in 2 cases, so I can fix those. Lowercase. And let's see if it finds any other bugs. So it's still finding an error. It's saying operator triple equals cannot be applied to types number and Boolean on line 84. So basically here I'm taking index of to try and find if this search string is in the title and comparing it to true. But index of returns a number, it doesn't return a Boolean. So what I really want to be doing here is saying the index is not -1. And with that, TypeScript should be OK with all of our code, and I should be able to refresh this, and everything should be working again. So it's really useful for these simple little mistakes that can sometimes be really hard to track down. Like there were 7 or 8 bugs we found just in this code here, just by adding 2 type annotations. And they're not that hard to track down in a code base of 100 lines, but if you have a 100,000 line code base, this could be something that's pretty hard to track down. Also, it's really useful for refactoring. So if I, for example, changed, if I could spell, if I changed the title parameter, instead of calling it title, I called it name or something like that, and called it name here as well, then TypeScript will find anywhere that name property is being used and tell me that that title property doesn't exist anymore. It's really useful also for refactoring your code. And one other cool kind of feature it has, if we take a look at that API service, you can see I'm injecting $HTTP, or no more $. I'm injecting HTTP and using the type annotation, and I'm saying private here. So what that means is it's doing 2 things. One, it's checking to make sure that no one outside this class is using it. It's just a compile time constraint. It's not actually going to stop you from using it, but it'll give you a warning if you do try and use it. And 2, it makes it a member variable of the class. So without private, I'm going to start seeing some errors because anywhere I'm using HTTP, I can no longer call it this.http. It's just a parameter in this constructor function. So it's just a really handy kind of shorthand syntax for assigning your constructor parameters directly to be member variables on your class. And you could also say public if it was something that you could actually use outside of the class. And one really useful ES6 feature, when you're using classes for everything, you can see this is a service, and all a service is in TypeScript or in Angular 2 is just an ES6 class. So when you're using classes for everything, you're going to need to use the this keyword for everything. And when you're using the this keyword in JavaScript, you're probably going to want to kill yourself because it really does not work how anyone would imagine. So for example, before ES6 came along and had arrow functions, if I did this same line here with just a normal function, so if I just said function, this is going to break. So if I run this code, it's not going to work anymore because the this keyword no longer refers to my class, it now refers to this function. So by using arrow functions, your this keyword is going to do what you would think it would do, and it'll actually be the same inside your arrow function and outside the arrow function. So that's just a really useful ES6 feature that you get if you're using something like TypeScript or any other ES6 transpiler. All right, so what do we got next? So yeah, here's some resources if you want to start learning ES6 and TypeScript, some blogs and articles about getting started with them. Components. So Angular 2 has this new component system, and this looks pretty different from, say, Angular 1. So in Angular 2, as we've seen, our components look something like this. So I have a little zippy component here, defining a component and a view and some logic in the class, and it opens and closes. In Angular 1, that could look pretty different. So I have an example here. I'm not going to go into it because I have it in the slides. So let's get back into full screen here. So on the left here, I have an old, like, kind of Angular 1.0 style component where we are injecting everything into our directive definition object and using a link function and using things like adders.observe to watch for changes to parameters that are being passed in, and we're putting everything on the scope. And that looks drastically different from how our Angular 2 components look. But there's a way to actually write Angular 1 components that is very similar, semantically at least, to how Angular 2 components will work. So on the right here, I have another component still using Angular 1, but using ES6 classes, using controller as and bind to controller. And what I end up with, if we go to the next slide, it's on the left, and I'm comparing it to an Angular 2 component on the right, is that these are semantically very similar. The only difference is some syntax changes. So on the left, we're using directive definition object to get all that metadata in there. On the right, we're using decorators. Other than that, these are pretty much the same. The classes that we actually have controlling this component are almost identical. The only difference is how we're doing dependency injection. So you can actually start using Angular 1 components or Angular 2 components in Angular 1 just by sort of changing how you write the Angular 1 code. So just by avoiding scope, that's a big one. Avoid scope a lot. And don't use link functions for things like components. It's fine if you have like a custom validator. You could use the link function for that. But for components, try and use isolated scope, controller as, bind to controller, ES6 classes, and you're going to get like 80% of the way to an Angular 2 component. And actually, Angular 1.5 is on its way out. Well, it might still be a little while. But when it comes out, they're going to add a lot of features that let you write code that will migrate very easily from Angular 1 to 2. So keep an eye out for that. For example, they're going to be introducing a module.component function instead of using module.directive, and it'll just let that syntax get even more similar to the way it is in Angular 2. So Shadow DOM. So let's take a look at how Angular is handling our styles. So if we take a look at that home component and we expand this view out, we can see that I'm inlining all my styles in the component, and I have a style movie poster where I set the max height to be 200. And in the details one, where it's not inline, it's in its own file, I have that same class defined where I set the max height to be 350. So this shouldn't work if we actually run the code, and it's in a working state. If I inspect this element, we can see that it has a max height of 200. If I go into this one and inspect it, we can see it has a max height of 350. So how is this actually working? Basically, by specifying our styles in the component, Angular is going to totally encapsulate the styles in that component. It's going to kind of namespace them. So you can see the class we're using here isn't just movie poster. It's this movie poster with an annotation of ng content NSY1. Basically, Angular is going to generate some namespaces so that when you specify styles for a component, it only goes into that one particular component. And this is a concept borrowed from Shadow DOM, which is part of this new web component spec that's making its way into browsers. And there are plenty of polyfills for it you can use today. Angular is actually emulating Shadow DOM, so it's not relying on your browser having any kind of support for it. So you can use it in any browser. And the cool thing with Angular 2 is that anything you specify, so if we go back to my component, anything you specify in this like styles URL will be encapsulated to your one component, but you can still have global style sheets. So I still have Bootstrap global, and I can access those style sheets anywhere. Whereas with Shadow DOM, if you're actually using real Shadow DOM, then your components will be totally encapsulated, and they basically won't be able to access anything in the outside world as far as styles go, at least. So yeah, there's lots of resources out there on Shadow DOM. You can start playing around with things like Polymer. Linked to some blog posts and articles on kind of getting started with that. One last thing I wanted to demo was Observables. So if we looked at my API service, we can see the functions that actually use the Angular HTTP service are not using promises, right? I'm doing http.get, I'm calling .2rx on it, and this converts it into this thing called an observable. And this is actually, I think, going to happen by default in later versions of Angular. So you won't have to call it .2rx. But then instead of doing things like .then, I'm calling .map. And in my component where I'm actually using this, I'm calling, I'm not on the branch that uses it. Let me go to master. So in my component where I'm actually using this, I'm calling .subscribe instead of something like .then. So what's going on here? What are these observables, and why is Angular using them? So I'm going to jump into another quick plunker to demo kind of what these observables do. So Angular is using a third-party library called RxJS, which, again, you can start using in any of your projects if you want. I've got a simple kind of starter app set up. So we're including jQuery, we're including RxJS, and we have our own script. And basically all we have is an input element and empty list. So what's going to happen is I want to start typing something in here and have that query Wikipedia and show all the results in a list. And I'm going to solve this with observables. So I have some starter code where I just get the input element, get the results list, and I have some helper functions for actually querying Wikipedia and showing those results. But what an observable is, it's basically an asynchronous stream of events, or an asynchronous stream of data. I'm going to be kind of using the term stream interchangeably because they're a lot. It kind of is easier to think of them as streams than this thing observable that you're not familiar with. So we might start by creating a stream of DOM events. So we could create a stream of key up events and then eventually map that into a stream of text and then a stream of server responses and then an actual stream of DOM elements. So we can start by doing something like rx.observable.from event. So I can pass in this input element and say I want to make a stream of all the key up events. So I can say key up. And then I can subscribe to the stream to see everything that's being output. So if I say subscribe, data, and then let's just log out that data. OK, so we bring up the console, and I start typing some stuff in here. We'll see a stream of events that starts being output. But I don't really want the events. I just really want the text that I'm typing in. So I could take this stream of events and map it. So all the array functions that you're used to using, like map and filter, you can use on observables as well. So I could say map this event, and we'll return event.target.value. Let's try that out. So now when I type stuff in here, we see we just have a stream of text now to work with. We might not want to hit the server with events when there's just an empty string in there, or if it's too short. We don't want to search for an article that's like an empty string. So we could do things like filter that data. I'm running low on time, so I'm going to skip over most of this. But you can do things like filter the data, debounce the data so that it only sends an event every certain number of seconds, filter out any duplicate events you're sending. Eventually, we're going to get the stream of strings that we actually want to query the server with. So with that, we can map those strings. So I'll call map again. Map those strings into a call of search Wikipedia. All right. So return search Wikipedia for that term. And what this is going to do is it'll call this function that returns a promise. Thankfully, RxJS actually works with promises really well. So it'll take that promise and convert it into an observable. So we're all good there, except if we look at our stream, it's not a stream of responses from the data. It's actually a stream of these promises, or a stream of these observables. So we kind of have a stream of streams now. It's sort of like we have a nested array, because when we make a request to the server, that gets us back an observable that will only ever have one event in it, which is the response from the server. So we can flatten that array out by calling flat map. And with that, and I also don't really need to have this function here. I could just call search Wikipedia directly. So with something like that, we should now be getting a stream of actual responses from the server. So here's all the articles that have the word test in them. So just from there, I can use this show results function. So we can call show results with the data. And now if I search for something, it should give me, when it reloads code, it should give me all the articles that have the word cheese in them or something like that. So there's a whole bunch of other sort of higher order functions you can use here to filter out the data. We're sending a lot of unnecessary events right now, but just for the sake of time, I'll skip over that. Now, if you're totally new to observables and you're thinking, all I wanted to do was send a request to the server and get a response back, and now I have to adopt this whole new paradigm in programming, this observables thing, there's actually another way. So in Angular 1, if you didn't like their built-in HTTP service, you're kind of out of luck. You kind of had to use it because of the whole digest cycle, and third-party libraries aren't going to know about it, so Angular won't know when the third-party libraries return. You don't have that problem anymore in Angular 2. Because of this Zone.js library, it magically knows whenever a third-party library finishes doing something. So I could use something like window.fetch to do all my HTTP requests. This is another new browser feature that's being implemented but not supported widely, but there's obviously polyfills for it. So I can just call window.fetch and start working with the promises directly, and I don't have to do anything like scope.apply like you would with Angular 1. So that is just about all I had. So it doesn't look like I'll have time for questions, but I'm going to be at an Angular AMA at 3:45, so if you have questions, come ask me there or just come up right after this talk. Last of all, my name is Rob McDiarmid. You can hit me up on Twitter at RobIanMcD. I work at Konrad Group. It's a great place. If you're looking for a job, come hit me up and come check out our new brain station space at King of Spadina, which is opening up pretty soon. So thanks a lot.